Welcome to our podcast series, Inside Semicon. In today's episode, we will be discussing how silicon has defined the semicon industry and is now also starting to define other industries, such as watchmaking. Hi John, good to see you again.
Thank you,
Tom. Today here on Inside Semicon, we're talking about silicon. Again.
Yeah.
Right? But it's an interesting topic. And
yeah.
First thing I thought when you mentioned silicon, I was like, that's sand, right? So help me out here. Explain to me, what is silicon exactly before we dive into the details?
Yeah, silicon is a rather unique material in the fact that it can be used and manipulated to make a lot of various items. And because of its properties, when it's manipulated correctly, it has a low thermal coefficient of expansion, which means that heat does not really affect it to such a large degree as, say, stainless steel. And it's also not affected by magnetic forces, which means obviously then that it doesn't, show true north or true south. So there are some inherent abilities within the actual substance that allows it to be used for specific and more dynamic areas that it can focus on to allow it to get the best out of devices that you wouldn't think, because everybody thinks, silicon chips, semiconductors, yes, it conducts, but yes, it insulates. So it's a semiconductor. So it's also to be used in its purest form with silicon itself. And I mean, one of the areas that I wanted to talk about, we were mentioning about spares, but I wanted to take a bit of a break the paradigm, so to speak, and get people to think outside the box here on this. So one of the areas obviously is, it's something that not a lot of us have, which is time. But we have, as an example here, I have an old Casio watch. It's completely digital. Everything in there is digital, from the LCD screen to setting to pushing the buttons. It's all basically made on in terms of the silicon inside. So it's an actual digital watch.
Yeah, nothing analog about that.
Yeah, exactly, correct. So that's a very important one. But then obviously with people examining the new structures and the new lattices that go into making silicon, and I have my iPad open, so I wanted to make sure that I give the right dates here. So people started experimenting with silicon in around 1990s, and a person called Ulysses Narden-Freak in 2001 actually managed to kind of break the paradigm with silicon. And what he did was he actually, managed to manipulate silicons into, springs and coils. So obviously with the watch industry, always trying to improve and trying to pack more into an analog watch, the likes of, say, Rolex or Swatch, Patek, the high-end ones, they want their watches to be obviously, even more precise. And they thought, well, if we take out the stainless steel elements and replace them with silicon, then, we can get a bit more in. Heat doesn't affect, because the thermal coefficient is lower by silicon. Also, it means that magnetic fields doesn't affect the movements, the time movements, so they're even more precise. So then what you end up then with is, basically it's an old broken watch that I had lying around, bit of a hoarder, Tom, so I always tend to keep these things for some reason, and they always come in handy in these podcasts. But here you can kind of see through the face, and obviously for people listening, it's easy to look this up online, that when you expand out the analog watch, you will see all of the springs, the cogs and the fulcrums and the hairsprings that are inside in this. And then these high-end watch manufacturers then, at the end of the day, they decided to incorporate them into the watch. So it's more about the fact that silicon is actually crossing not just from the digital, but now it's going into analog.
Yeah.
Which is kind of a dilemma in the way that silicon was designed to basically carry, we were using it to carry signals, digital signals from point A to point B.
Yeah.
Now we're using it in an analog world. So now it's actually physical springs, physical cogs, and physical moving mechanisms.
Yeah, because most people that don't know anything about semiconductors or chips or whatever, they will think of silicon as purely something that's used in semiconductor manufacturing, right? Yeah. But what you're saying now is actually it's progressing past that. We're using it in so much more forms and applications. But aside from making the watch more accurate, because I think that's what it eventually does to these analog watches, right? What are the other benefits for watchmakers? I mean, is it cheaper? Is it more expensive? Like, what's their decision process?
Yeah, I think that on that question, more so about, obviously silicon is way more accessible. I mean, and it is cheaper, obviously. And I think what it does as well is it allows people to be more creative with the timing mechanisms. So in each, of the watches you have, even though they're analog, you have alarms on there. You have different abilities to change the date and the time. So the lighter the watch is, I mean, you can have a watch which can do a lot, but then it needs to be maybe 12, 13, 14 mil thick if you have different complications in there. But by having silicon and it's lighter, you can have a bigger watch, but it actually feels lighter than a watch that's half the size with half the complications. So it does give the watch industry the ability to make more complications in the watch and then not have the restrictions of, heat, or if it's near a magnetic source, that it will start losing time, seconds over the next period of time. Plus, I think as well, to manipulate silicon is probably easier than stainless steel. Silicon is very pure. With stainless steel, you do have impurities, even though you do have higher grades of stainless steel. But silicon is so pure because obviously it's made in a process where the manufacturing process is built in a clean room. So because of that, you can be 100% sure that the actual process and the actual purity of the silicon that goes in is there, and it will never, degrade. It'll never corrode, and there's no inherent flaws in it. So the structure is actually very strong. But it does allow them then to maybe think outside the box as well. If they can pack more in and have these silicon springs and silicon cogs turning, can they actually have a smaller, cog turning a bigger cog to allow more energy to be stored internally to try to get to a perpetual watch? In the old days, they had the one where you could move your wrist and you could wind the watch.
Yeah.
But then you had to have a fulcrum in there, which is quite heavy because it had to also be able to move around. But if you made that from silicon, that felt a bit lighter, but then that would have to drive something else which had to be made from silicon. So it does allow them, I think, to think a bit further on the watch design.
Yeah. So the watch industry is really moving towards using silicon instead of stainless steel.
I think that it's opening up. I mean, it's only been around since 2001, and I think since maybe... I'm taking a guess here. I'm sure there's some, chronologists out there that will probably, grit their teeth when I give dates and times, but probably 2016 year, I think, is when they really opened up to actually saying, yes, we are installing this now in our watches. Yes, we are officially using it. So on the particular, spring, it's now called siloxy. I think it's, I don't know if it's patented by Rolex, but they're actually saying, we use this in our watches. Yes, we're using silicon springs. Yes, we're using, hair springs, etc. So it's becoming an accepted fact that silicon is now being used within there. But the next step for it, obviously, is really what they can think of to make with the next level silicon.
All right. So having heard all of this, right, what are there any drawbacks for using silicon over other material? Like, are there any disadvantages?
Honestly, I can't think of any, to be honest with you. I mean, yes, silicon is brittle, but if you're wearing a pretty expensive piece of kit, you're not going to be, hopefully banging your wrist against the wall, but then you break it anyway. So it does have the ability that, it is brittle. It's not very flexible. I mean, there are companies that are currently trying to experiment with making flexible, integrated circuits and so on. But I think that the positives far outweigh the negatives. You'll always have some negatives with any new material. But I think with this, it's at this moment within the watchmaking industry, I can't see it. I mean, maybe another industry could be pens, for instance. That when you're writing with a pen, you have the stainless steel ball, which is in the top of the pen, so to speak. Like when you have the pen itself in the top here. This is a digital pen, so I don't know why I'm showing it to you. But there's a ball in a normal pen. So maybe if that ball was made from silicon, then, and made in a clean room, then they can get the dimensions perfect. And then you don't have the stutter sometimes. So maybe with the higher end, Mont Blanc's pens, for instance, that they would use silicon in that as well,
And then reverting back to, our industry logistics, right? And of course, we're mainly focused on high tech and the semicon industry. how do we have to do we deal with any challenges related to, transporting silicon? I mean, is it because you said it's brittle? In terms of logistics, where do we have to adjust our standard processes?
I think it's mainly when we get move the silicon, actually silicon ingot. It comes, I think it's 0.5 meter high, and it can be different sizes in diameter. But as you said, in that form, it's not so brittle. It's when they start chopping it up into small little wafers, then that's when we have to be very careful. But what we find then is that from a logistics point of view, we have to watch simple stuff like vibration. If you've got a glass, and if you keep tapping it enough, the harmonic frequencies will build and build and build, and then it'll eventually shatter. The same with the silicon. If you're transporting that, and if you don't have, as an example, an air ride truck as opposed to an old spring truck, those vibrations can cause damage to within certain tolerances of equipment that's been shipped. So from us to have to look at that, ideally, we would have a maglev truck, which would be on magnets, and then that would go from A to B. So, but unfortunately, we're not there yet.
Not yet.
But it's something that we are, looking at. But we also have that as well when we're moving the parts around in warehouses. You don't just put it on a pallet truck and move it from point A to point B. You actually have air ride, like hovercrafts, so to speak, but they're smaller. But then that actually allows a cushion of air so that there is no vibration coming through, and if it goes over a small dent or whatever in the warehouse, the equipment does not feel that. So it's all the times about removing not only the vibration but any external things like humidity, temperature control, air control, etc. But that's how the logistics industry is continually changing, and we have to continually adapt for that, because not only are we shipping, as an example, watches out the front end that's worth a lot of money from the point of view of it's a watch, but at the back end, when they're actually making some of these internal workings, even though that equipment is still very expensive, some of the raw materials like silicon are cheap. So we do have a dilemma in that we have to be high end at the front, and then we also can ship on pallet trucks and normal regular trucks at the back, but we do have to incorporate them, and that's quite a tough logistical challenge to know at what point of their process do we put in the particular equipment to protect their valuable merchandise.
Yeah, and that's where it really becomes significantly important that we understand what our customers are doing, right?
Yeah, that's correct. I think I've said this a few times, is that I also wrote an article on one of the Semiconductor Digests that unless we're inherently engaged within the process and the future of what they're developing, we can't develop a supply chain to allow us to ship the product the way it needs to be shipped. If you already have a product and you said, okay, I need to ship today, it could take us a couple of weeks, couple of months, and maybe even a year to understand how we need to ship this to their particular requirements. Whereas if we were involved in the new releases or knew what direction they're taking 6 months before they release the product, then we could actually build the supply chain around moving that product from point A to point B. So I think that communication and also the customer bringing us more into the fold to let us know what we can do when it comes to especially semiconductor shipments, how we can actually overcome any of the problems that can result in damage to their product.
So back to silicon, right? We're using it in watches now, or the industry is using it in watches and many other products. Where do you think this will go in, let's say, 5 to 10 years? Will we see silicon in everything, or? I
think it's a good question, and it's, again, kind of hard to look into the crystal ball. But I think the way it's going is that, yes, the digital side will always have it. And, we're now in the AI age, which, came out of nowhere, really. And I think that within the products that we're using, we're always looking to make things faster, quicker, or cheaper. So it can actually cut across areas in the analog world that we would not have thought about. So like I said, like maybe the next is pens. Maybe they're already doing that. I didn't look that up, actually. But maybe pens are next. We have watches. Could it be that there's, I don't know, like silicon stands for televisions? Could it be that we're making, the pots and flour out of silicon? It's a very reusable, recyclable product, silicon. cheap to manufacture, and it's plentiful. So I think if there's a way for people to actually exploit would be the bad word, but to use the silicon, to exploit the silicon and the properties that it has, and to find a niche market for it, then you don't know where it's going to end up. There will be areas where we can probably find a new arena for it. I don't know, maybe Windows.
Could be anything.
It could be anything. Yeah. I mean, because if you want blackout blinds, could they be made from silicon? That if we can manipulate it enough, can it be that you then pull down your silicon blind because it's black, it's impervious, to light if it's thick enough. So yeah, it can be in anything, but I think it's just that people have to rethink the materials that we're using currently. We're still heavily reliant on the plastics. We're still heavily reliant on steel because of the strength. But if you have something that doesn't need too much strength for load bearing, then I think silicon, may be an option. Yeah. But again, that's me summarizing and theorizing. Yeah. But
it's still it's amazing to me to think that all of this came from the developments made in the last 20 years in semiconductor research, right? That's amazing to me. That we're already progressing and using it in our daily products and items that we use every day. And then to take another step back and say, well, initially silicon is manufactured from sand. That's it's almost mind blowing.
Yeah, it is that one of the most, as I said, it's like sand. You think of water. It's everywhere, and it's quite malleable. I mean, sand is used to make glass. You know, so the lattice properties of the glass and the semicon, the actual silicon are kind of the same. So it's just a different process we put it through. But actually, on that there is talks of maybe glass quartz taking over from silicon. So we could be going again around in a circle in a couple of years if they manage to develop, quartz and use quartz instead of silicon. So it's an ever changing, which is why it's a great, fantastic, interesting industry. Yeah, it's always changing. There's always new things around the corner that we never thought about.
Yeah, it's very interesting. Yeah. And thank you for sharing your thoughts on this. Appreciate your time today
and my watches
and your watches. Yeah, and I hope everybody found it as interesting as I did.
Okay, thank you very much. Thanks for having me.
Thank you.
Thanks for listening to today's podcast, Inside Semiconductors and the Semiconductor Supply Chain. If you found any of the topics we discussed interesting and you want to find out more, you can find me on LinkedIn at John Desmond or go to Kuehne+Nagel's website.